And now it's time for our next presenter, who is Ennery Leon, corrosion engineer from TACA Global. And he's going to be telling us about use of corrosion coupons for internal corrosion monitoring in the oil and gas industry, where to place them. Ennery has worked in companies such as Penkeven, Petroquímica de Venezuela, TNR Engineering, PDVSA, Petróleos de Venezuela, Tata Steel in the Netherlands, and he currently works at TACA Global in the Netherlands as a corrosion engineer. He is mainly focused on the management of corrosion control and engineering development for traditional projects in the oil industry, as well as the innovative projects for capturing and transporting CO2 to be stored in reservoirs and hydrogen generation offshore, contributing to achieving Europe's goals to mitigate global warming. Okay, Ennery?
Hello everyone, welcome after lunch break. I hope that you had a good lunch. So, this session, we're going to change a little bit the topic. We're going to maybe stop for a couple of hours talking about automation. At least in my topic, we are going to go back to the roots of corrosion control with simple tools as corrosion coupons. Automation and digitalization, they are key elements nowadays in industry. But we need to keep an eye on the traditional tools that we have to control our processes and to monitor if we have an issue or not. Because we might be injecting everything in the correct way. We might have a very automated process. But if we are not double checking if that corrosion inhibitor or scale inhibitor is doing its job, we are not winning anything. So I'm more than glad to present this material to you. It's going to cover a little bit of a practical approach and a theoretical approach for those that are not aware of the challenges that we have with corrosion coupons. So I hope that you enjoy. We will have a nice questions and answer session at the end. Shall we start the clock? Yes. So, the content that we will discuss today. You will hear about corrosion coupons and its selection. What can you get from corrosion coupons? Advantages and limitations of the corrosion coupons. What should be the location of the corrosion coupons in the system? Exposure time, interpretation of corrosion coupons data, and questions and answers. The first challenge that we have when we need to monitor our system is what kind of technique are we going to use? Usually, that depends on the type of process that we have, the materials, what kind of media. But maybe you have heard something about the budget. If we don't have enough money, we might not have a lot of options to choose our monitoring tools. Therefore, corrosion coupons, they are selected most of the time because they are quite inexpensive, simple to install, simple to retrieve, and the lab analysis, they are quite, let's say, low cost. But we have other options for those with a little bit of extra budget available. You could also define what kind of technique do you want to use based on what kind of information do you want. Do you want to have direct information? Then you need to use corrosion coupons or a spool piece, electrical resistant probes, linear polarization resistant probes, or electrochemical noise. The advantage of having a direct technique is that you will know for sure your corrosion rate. You are not going to assume, you are not going to think something, no. You will know what's going on in your system. You will know how many millimeters per year you are losing because of corrosion. So that's direct. Those are the direct techniques. You also have indirect techniques. Those are the hydrogen probes, quite useful to assess embrittlement, for example, with hydrogen. You also have, as an indirect technique, the water chemistry analysis. That's quite simple, quite interesting because every day, every week, every month, you can take a sample and you can have an idea of how is your process, if your pH is as it is supposed to be, if your H2S content is as it is supposed to be, if the assumptions that you made during your design are still are a reality. You can also do some solids analysis, gas analysis. And then you also have another type of techniques. Those are the non-intrusive. So you don't have to get into the process. You can get information from outside. You don't have to bring any instrument, technique, or any device into your process. Typical example, ultrasound measurement. You can measure the wall thickness of your asset from outside. And you also have another good example, electrical field mapping. Again, as an indirect and non-intrusive technique, you have hydrogen patch probes, acoustic monitoring, and thermography. This is just this summary is with the intention of opening your eyes for those that might be involved in corrosion monitoring, but maybe you only heard about corrosion coupons and corrosion probes. There is a large set of tools available for you guys. Today, we will have a nice conversation about corrosion coupons. So, another way to assess what kind of technique is the most suitable for you guys is what's in your system. Are you handling just water, gas plus liquids, oil or oil multiphase, or gas plus water? Because depending on the media that you are handling and the type of corrosion that you expect, you will be able to match these techniques. This is just an awareness table, so to say, so that you are aware of what you have available. As you can see in green color, corrosion coupons, they are quite useful because they can help us to monitor a lot of, or in every media, you can monitor almost any type of corrosion-related issue. The only type of problem, corrosion-related problem that you can't monitor with corrosion coupons is environmentally assisted cracking. That's the only one that you need to look at hydrogen probes or a patch type hydrogen probes. With this, what I want to say is that corrosion coupons, they are quite useful, and that's why we are using them since the beginning of operations in oil and gas. Another advantage related to this conference is that we can monitor the efficiency of our chemical injection program. If we're using corrosion inhibitor, scale inhibitor, or biocides, you can use corrosion coupons to monitor their efficiency. Well, basically we have two types of corrosion coupons. We have the laminar type. They are also called stripe. They have normally 3 dimensions. They can be 2 inches long, 3 inches long, or 6 inches long. We also have another type that is called flush disc coupons. They are also called flush. The type of coupon that we normally use in the oil and gas industry is the laminar one. It's used almost for every application. And depending on the system that you want to monitor and how much space you have in the pipeline, depending on the internal diameter, you will be able to place corrosion coupons, maybe only 1 set, or 2 or 3 sets using multiple locations. The way they look inside the process is that we will place them from outside. So this is a direct technique, as I mentioned before, and also intrusive. Depending on where you think you will have corrosion, you will place them at the top of the line, middle, or at the bottom. We also have a second type of corrosion coupon, that is the disc type. This is quite useful when you have one of the 2 challenges. One of them, if you want to use the pigging or cleaning pigs, you need to use this one if you don't want to retrieve them during pigging operations. We have some operators that they need to run a cleaning pig every week, for example. It would be a headache if you have to retrieve the corrosion coupons or corrosion probe every week. So basically what they do, they use flush disc corrosion coupons. Another advantage of using this type of coupon is that they are quite short, not even 1 inch thick. So you can place 2 or 3 of them inside a small pipeline. If you need to monitor corrosion, top, middle, and bottom of the line of a small diameter pipeline, this is your best option. Because as you can see here, you can monitor the 3 locations with a very little space. So, what can you get from corrosion coupons? We can get at least 6 important items. The first one, normally they are used to provide us with corrosion rate as a direct technique, as I mentioned before, because we can measure the mass loss in a period of time, and then we will just do the math using simple equations, depending on the density of the material, to see what is our corrosion rate during the period that the corrosion coupon was installed. Another information that we can get from the corrosion coupons, but unfortunately is not that commonly used, is that you can get information about your pitting rate. One of the biggest mistakes that we can make as operators is just to retrieve corrosion coupons, ask the lab, please, just tell me the corrosion rate based on mass loss. Because depending on the type of corrosion that we could have in our system, you could have pitting corrosion, and that's another headache. So you need to be aware of what kind of corrosion you have in your system. And the third type of information that you can get from corrosion coupons is you can get to know your biofilm. Most of us, we have heard about microbially induced corrosion, MIC, MIC, different ways of calling it. And this is caused mainly by microorganisms in oil and gas, SRBs, sulfate-reducing bacteria. They are the most common microorganism involved in this type of problem. And we can get to know them if they are present in our system. Once we retrieve corrosion coupons, we can take those coupons to the lab, take a nice picture, and see what kind of microorganisms do we have. And then, if we know our problem, we will be able to specify the correct type of biocide. Similar to when we go to the doctor and we need to get antibiotics, if they don't know what kind of bacteria we have, they are going just to be guessing for the solution. So we, in oil and gas industry, for corrosion control, we need to know what kind of microorganisms are present in our system. Then, with corrosion coupons, we can go even one step further. We can know what kind of microorganisms do we have, but we can also know what kind of damage do they do to our system. Because as you can imagine, it's not the same story to have localized corrosion that you will have maybe 5 millimeters per year of material loss just in a, let's say, 1 square centimeter. You will have a leak in a couple of years maybe. And then if you're using corrosion coupons just to calculate uniform corrosion, you are lost. You are doing it wrong. You might have a misleading impression that you have low corrosion rate. And additionally, with those corrosion products that we can get on the corrosion coupon, we can also send them to the lab and ask the lab, hey guys, can you help me to understand what are my corrosion products? Because that's also evidence of the type of corrosion that we have. So if you have oxygen as part of your corrosion products in oil and gas, that's quite strange, because usually we don't have oxygen in our systems. It's not common. We can have H2S, we can have CO2, but if you have as a corrosion product oxygen, that should be a red flag. Could be a risk for your safety, could be a sign that maybe in one injection pump you have a seal that is broken, and then you have oxygen coming into your system. So this is one of the advantages of using corrosion coupons, not only for mass loss analysis. And maybe not applicable for our daily basis business, but corrosion coupons, products can be analyzed also in more details. Usually we say, yes, it's just iron oxide, but for academia, or if you are running an investigation project, that might not be enough, because depending on the specific product that you have, you will have different products, like a hematite or magnetite, and then you need to run an analysis into the compound level, okay? what are the advantages that we have with corrosion coupons? Its installation is, as I already mentioned, they are quite inexpensive. You only need a access fitting and a sample of the material to be replaced every time that you retrieve them. You could even reuse corrosion coupons if you want to have a long-term evaluation, but it's not recommended. You can also, one of the advantages is that you can run simple and direct analysis, like visual inspection and mass loss corrosion rate calculations. You don't need complicated electronic devices or extra instrumentation or highly qualified technicians to do this kind of activities. They can be used in any environment, and they don't have restrictions with temperature. For example, corrosion probes, they have limitations around 250 degrees. You can't use corrosion probes, but corrosion coupons, if you can make a pipeline with carbon steel, you can use a piece of carbon steel as corrosion coupon, so no limitations. And you can also use multiple corrosion coupons in one access fitting. As you have seen in this type of picture, for example, you could install 6 at a time in one specific location, and if you have a corrosion monitoring program, you can say, I will retrieve the corrosion holder, but I will extract only one coupon and reinstall the other 5, or maybe replace that one. And then you will have, if you do this every month, you will have a 6-month monitoring program to know your system for 6 months. But you are doing that in only one location. You don't need 6 access fitting in your pipeline. So that's quite interesting. And maybe one of the most important advantages of the corrosion coupons is that they give you information about the type of corrosion. Other techniques, they only say you are losing material, period. That's it. You only get a number. But with corrosion coupons, you can get a lot more of information. And this is the most interesting for us, the corrosion engineers. What type of corrosion do I have? H2S related, CO2, erosion corrosion, hydrogen embrittlement, you name it. But they are not perfect. That's why we need other techniques as well. Why they are not, what reasons they are not perfect? Well, they can't be used to detect rapid changes in the process. If you have an offset in your system, for example, in refineries, that maybe one day you are receiving crude oil from one supplier and the day after you are receiving it from another supplier, with corrosion coupons, you are not going to notice if there is an offset in the specifications. For that one, you need corrosion probes. You can't monitor localized corrosion as well. And, or at least you can find them before coupons are removed, even with a longer lasting test. Coupons, I already explained this one, they can be misleading in situations where the corrosion rate, they have big differences because of the time that they are installed and then you retrieve them. Maybe the corrosion happened in the last, let's say, 1 week, 2 weeks because of an offset in the process. And then you think that you have everything under control, but it's not the case. It's a total cumulative measure of corrosion over the entire exposure of period, and cannot be used to define when or why the corrosion occurred. You will only know that you had an issue in the, let's say, in the last 6 months where they were installed, but you can't say when exactly it happened. For example, if you have when you retrieve the corrosion coupon, you have a cracking, you are not going to be able never to say when that cracking initiated. And the propagation of that crack is not possible to have information about it. So as I already said, corrosion might happen just at the end of the period, and you don't know, could be maybe the corrosion happened at the beginning of the installation, at the end, we will never know. Depending on the philosophy that you have in your assets, this might not be a problem, because sometimes we want to use corrosion coupons or corrosion probes just to make sure that everything is stable. For example, onshore, we have assets for gas storage. We could say that maybe 24/7 we have the same conditions in the gas storage facilities onshore. way different to our platforms offshore. So for onshore, it's more relaxed, so to say, because we just want to use corrosion coupons to detect possible corrosion issues afterwards. So it's okay. We can, if you know your system, you can use them in the proper way. And another risk is that they are intrusive. If you are using intrusive coupons, they can prevent using picks or cleaning tools or intelligent line inspection tools. And they also represent a risk from the safety point of view, because each time that you want to retrieve your corrosion coupons, you have a risk of having a release of toxic substances. But okay, now let's get into our topic today. Where do we want to place those beautiful corrosion coupons if they are so useful? Well, if you install them in the wrong location, you're going to get the wrong data. So basically, you want to make sure that you install your corrosion coupons in the right spot. When you are in the design phase for new facilities, you want to make sure that you are placing them where you think that will be water accumulation. Basically, if we don't have water, we don't have corrosion, as simple as that. So during your design phase, you want to make sure that you identify those locations where you will have water accumulation. In existing and operating systems, you want to monitor you want to monitor locations where you might have not only water accumulation, but also impact, okay? Because then you might have also erosion corrosion. If you already had corrosion failures, that's a clear indicator that you should have a monitoring system in that spot. Additionally, in operating facilities, you are supposed to comply with the legislation and you're supposed to do inspection. Once you get the feedback from those inspections, if you detect high corrosion rates and you don't have monitoring systems, you might want to install corrosion coupons there. As a general guideline, we want to install them where we have dead fluid areas, high velocity fluid, downstream of points of possible oxygen entry, locations where water is likely to collect in sour systems, sites where failures have occurred already, amine and glycol streams containing sour gas, vapor sections in sour glycol regenerators, and areas where a liquid or vapor interface occurs. So another example of why location is so important. When you have a change in direction, in this case, if you are going upwards, in the zone A, if you have low flow rate, this area, you might have accelerated corrosion because the corrosive water would go up because of the pushing of the gas that is going through the line. For this specific line, we're talking about wet gas pipelines. So at this spot, the water would tend to go up because the gas is pushing it, but because of gravity, it will go down. And then as long as we have a wet pipeline, we will have corrosion. Then on the section B, we shouldn't expect corrosion because basically the gas will be pushing the water and we don't have accumulation. And then on the spot C, we might have, again, corrosion. And if we have high flow rate, this would be a critical spot because we would have not only corrosion, but also erosion corrosion. So this would be a good location to place an access fitting for corrosion coupons. If we have a change in direction downwards, then we want to, we will have problems in the spot C, similar story to what I explained here. Gravity will be pushing the water downwards. And in spot A, we will have the highest corrosion in this situation. So we would like to install corrosion coupons here. And if we have a riser for a transmission line, the section A, okay, section A and B will be the ones having the biggest problem with corrosion. And those would be the locations where you want to place your monitoring devices. Another way to define where to install the corrosion coupons we need to use mathematical models to define the flow pattern that you expect to have. And then you can ask you need to ask yourself these kind of questions. Where can we have water accumulation leading to higher probability of corrosion problems? At 12 o'clock, between 4 and 8, meaning at the bottom of the line. You need to answer those questions because depending on the flow pattern that you will have different challenges. To give you just one example, if you have annular flow, you want to place corrosion coupons or corrosion probes both on top and at the bottom of your system. Because if you are monitoring only one part, you might think that you are only having corrosion problems in that part, but you are overlooking at the problems in the other spot. Luckily for us, we have 4 ICDA standards. These are the internal direct corrosion assessment standards from NACE. We have one for the multi-phase flow assessment and a similar one for wet gas. Basically, what you want to use is to correlate, the gas velocity and the liquid velocity in your system and try to define what kind of a pattern do you have. And then you will define the monitoring techniques that suits your needs. You also have another standard for pipelines carrying dry natural gas, or normally dry natural gas. For this one key element that you want to define, what is your critical angle? That means that if you have an inclination higher than that number, you will have water accumulation. So in your design, you need to work together with the piping engineer or mechanical engineer to define what is the inclinations, the angle inclinations that you will have along the pipeline. The last standard that you have available to do this kind of assessment is for liquid petroleum pipelines. Then you have mathematical models to assess how much water accumulated you will have at the bottom of the pipeline. And also you will be able to design taking into consideration the density of the oil and the velocity of that oil within the pipeline. You will be able to predict if the water will be at the bottom of the pipeline, or if you are lucky enough, you will have some kind of emulsion, meaning a combination of water inside the oil. And I don't know if you knew, but oil is not corrosive. What is corrosive is the water. So if you have the oil always in contact with the internal part of the pipeline, you might not even need corrosion inhibitor, but sorry guys, that's something else. But unfortunately, it's not normally the case. We will always need chemical products to protect our assets. But these are easy tools or nice tools to make in an easy way predictions to see if you will have a problem or not. Another recommendation is that if you're going to install 2 or more access fitting to monitor your system, please place them at least 30 centimeters in between to avoid interferences between them. And corrosion coupons, they need to be installed in this way, parallel to the flow. It's the best way to collect data and also to avoid turbulence issues, especially if the coupon holder is quite long. Let's say in a 36 or larger pipeline, that if you go from the top to the bottom, this would represent a mechanical challenge for the corrosion coupon. This is a nice picture. Here, I think we don't need any mathematical model to predict where do we think that we might have water accumulation. Of course, in the lowest spots of the pipelines, most likely you will have water accumulation. And if possible, try to install access fittings in this area. With this slide, with this picture, I want to show you how corrosion coupons, they look in reality. They don't look like corrosion coupons. So that's why record keeping and proper documentation is so important. If there is a new technician or a new corrosion engineer coming to these assets and they don't know what's here, this could be a bioprobe, this could be a corrosion coupon, this could be nothing, just a cover. So we need to keep documentation up to date to make sure that we use our monitoring equipment as efficiently as possible. And I also wanted to show you a couple of examples that we need to keep a minimum distance between access fittings. Here, another couple of examples of how things should be done in a good way, with keeping the distance between two elements. In both pictures, you see a combination of corrosion coupons and corrosion probes. Well, we're almost finished, almost on time. What's the exposure time recommended for corrosion coupons? That's usually a interesting topic for discussion, because according to some standards, they would recommend two ranges. The short term would be between 15 and 45 days. And that, of course, will give kind of quick answers to your investigation. It might generate higher corrosion rates than long-term exposures. That makes sense, because remember, eventually when the pipeline corrodes, and if you are not feeding more oxygen or more aggressive substances, corrosion might stop. But if you are retrieving corrosion coupons every 2 weeks, they will be constantly corroding. And remember, the new pipelines, new materials, they have a higher level of energy, so they will tend to corrode even quicker than old materials. And short-term exposure time, it's useful in evaluating corrosion inhibitors efficiency if you don't have corrosion probes. There is another approach, long-term exposure time, between 60 and 90 days. You can detect and define pitting attack, and you can also assess microbiologically induced corrosion. There are a couple of notes and remarks that I want to mention here. So the first one is that because exposure time affects the test results, you want to be as consistent as possible with exposure time. If you say 45 days, try to aim all the time 45 days. Because it's suggested to have up to 7% plus minus time difference. To give you an example, in a 30 days exposure time, that would represent a difference of 2 days. So you should try to do the replacement every 28 or 32 days maximum. Some companies, they have a culture of retrieving corrosion coupons every 6 months. Nonetheless, the frequency of coupon change can and should be changed based on results obtained. If you retrieve corrosion coupons and you get low corrosion rate, you can save money. Why do you want to do that every month if you are having low corrosion rate? You can do it every 6 months or every year. That's what we do. We have the situation under control, and we do corrosion coupons retrieval once a year. And the last slide is that you need to be careful with the interpretation of the data that you get from corrosion coupons, because this standard from NACE, the 0575, this one makes it's specified for pipelines. So if you want to compare corrosion rates for heat exchanger tubes, that's a mistake, because usually they are quite thin. So the logic behind doesn't make sense to use these standards, okay? That was it. Thanks a lot. Do you have questions?